So what are the tools that you have to use?
R equals x squared plus y squared.
So r squared equals x squared plus y squared, or r equals the square root of the quantity x squared plus y squared. Okay, that's one of them. What else? What other tools do we have at our disposal?
We have the r cosine of theta equals
X equals r cosine theta. Another one? Y equals r sine of theta. And then the last one we have is that theta prime, our reference angle, is equal to the tangent, inverse tangent of y over x, right? But we don't use that one as much as we use those other three. Okay? So if I know that x squared here, oh, cut the brakes. If I know that x squared here plus y squared is r squared, and I know that x is r cosine of theta, I get that, correct? How do I want my polar equation to look in the end? I want it r equals, right? So I've got to do what with that? No, because there's an r in there. Yeah. If there wasn't an r in there, yes. Factor out an r, okay? Because there's an r in both of them. I'm going to factor out an r. That leaves me with r plus 4 cosine of theta. Right? Okay. Side note, and I'll put it over here on literally on the side, if I had x squared plus 4x and that was equal to 0, you would factor out an x. Then what would you do? Set what equal to 0? Just the stuff in the parentheses? And so then you would go x equals 0 and x plus 4 equals 0, right? And then you'd solve those. Okay? Algebra. Yeah? All you're doing here is algebra. So what are you going to do over in this polar one? R equals 0 and?
R plus 4 cosine theta equals 0.
Now, let's chat about those two. R equals 0. What is that in the polar world? R equals 0. What is that? Huh?
That would land on the pole.
It's just the pole, right? That's it. Okay? Is that anything other than the pole? That's nothing. So that's not going to help me. So we kick that one out. Okay? Then the other one, we solve for r. So r here is going to equal negative 4 times the cosine of theta. And that is the polar equation for this scenario. Okay? Now, to prove that, what we're going to do, or what I'm going to do, is I'm going to graph it. So it was a circle. Okay? So I am going to go into my equation template, and I'm going to go into the standard form of a circle. And it was x squared plus y squared plus 4x plus 0y plus 0 anything. And that gets me that. X squared plus y squared plus 4x was my original equation, which is a circle, not centered at the origin now, but it's centered at negative 2, 0, and it's got a radius of 2. Okay. Polarity-wise now, if I were to graph r equals negative 4 cosine of theta, it should go right over the top of this graph. R equals negative 4 cosine of theta. Right over the top. Okay. So they are one and the exact same thing. Okay. So x squared plus y squared is going to become r squared minus 6. Oh, oops, tip of brakes, that should have been in green. Minus 6 r sine of theta is equal to 0. So I'm going to, oops, and then this should have been in black. Hey, caramba. There we go. Now we're getting it looking pretty. R times r minus 6 sine of theta is equal to 0. So r is equal to 0. R minus 6 sine of theta is equal to 0. This first one is the pole, so we just kick that out. That leaves us with r equals 6 sine of theta as our polar equation for that. Okay? Proving that graphically, we have here now, let's see, if I go tab, oh, no, I can't go tab, let's just go to a new page. If I go in here, graph entry edit, equation, circle, standard, 1, tab, tab, 0, tab, negative 6, tab, 0, gets me there. Okay. Circle centered at 0, 3 with radius of 3. Then polar-wise, we said that that was 6 times the sine of theta. Gets us the exact same one. Okay. So that is changing from rectangular to polar. Now let's go the other way. Let's go polar to rectangular. Okay? A lot of algebra going on today. So let's continue on with it. If I gave you the polar equation, r equals 5, what is the graph of, or what does the graph look like of that polar equation? R equals 5.
Wouldn't it just be a circle around the 5?
The fifth ring. So I'd go out 5 rings. 1, 2, 3, 4, 5. I'd go out 5 rings, and it would look like a circle, 5 units out, right? Okay? Now, we still have the exact same tools. We still have x squared plus y squared equals r squared, or r equals the square root of x squared plus y squared. We still have x equals r cosine of theta, we still have y equals r sine of theta, right? We still have that our reference angle is equal to the inverse tangent of y over x, but we don't really use that, right? Okay? So, mathematically speaking, how can I take this? Now I have an r theta equation, and I want to infuse that with x and y. So I got to get rid of r, and I got to put x and y in there. How can I do that? Yes, ma'am.
You can substitute r to the square root of x squared plus y squared.
And that's going to equal 5 then, right? So I could do that. Okay. Can I make that look even prettier?
You can just square both sides.
Square both sides. And so I would get x squared plus y squared equals 25. And that is the equation of a circle centered at the origin with radius of 5, which is what my picture of our polar equation, r equals 5, is. Centered at the pole, radius of 5. Okay? Yeah? What if I did some other funky algebra right from the start? Because remember, the golden rule of algebra is what? What's the golden rule of algebra? You learned it way back when you were in 8th grade or a freshman. What you do on one side, you got to do the other, right? So could I go back here and say r equals 5? Could I say that, could I square both sides? Yeah? And that would give me then r squared equals 25, and then I could use my tool of x squared. Oops, let me go like this. Then I could use my tool of x squared plus y squared is r squared, and gets me that. Okay. One in amongst the same. Okay. Good stuff. Or great stuff for not a lot of money. Festival foods. No free ads. Okay? Alright? So, next one. Theta is equal to 3 pi over 4. What does that polar graph look like? Theta equals 3 pi over 4.
Would that just be like a straight line
Okay?
from the origin?
Okay?
Along the 3 pi over 4.
So I would first want to find out where my 3 pi over 4 line is, right? So that's this one.
And then it'd be just like a straight line.
Just going that way? Like a ray? Or would it truly be a line going in both directions?
I think a ray.
Just a ray? Well, let's see. Let's talk about this one. So we've got here, we've got there, I've got that. That's what I want. So we're going this way. Does everybody agree with that? That's my 3 pi over 4 direction. Now, let's go back to the original, or the equation that was given. The equation that was given was theta equals 3 pi over 4. Yes? Okay? In polar, I need an r and I need a theta. Right? I have the theta. Does it matter what the r is? No? Okay? So what we have graphed there is when r is positive, correct? Going in the direction of 3 pi over 4. What other kinds of numbers are there? There's negative numbers, right? So if I have negative r values, if r truly doesn't matter, then which way is that going to go? Through the pole going in the opposite direction, right? So that would be this way, correct? Okay. What other, there's one other kind of number out there. There's positive numbers, there's negative numbers, and there's 0. Okay? What if r is 0 in the direction of 3 pi over 4? What do I have then? What do I have if r is 0? We've already answered this question once today. Oh, I thought, oh, you're just flicking here. It's the pole. Yeah, it's the pole. Okay? So we're good there, right? So, that's what the polar graph of theta equals 3 pi over 4 looks like. What is it? What is it? What shape, what mathematical shape is that? It's a line. Okay? So what's the equation of a line? Y equals mx plus b, right? So I want, in the end here, I want this to be y equals mx plus b. Now, let's talk about y equals mx plus b. What two things do I need in order to give the equation of a line? I need the slope, that's my m, and I need the y-intercept, that's my b. Okay? Because it goes through the pole, and the pole in rectangular is what? It's the origin, right? So that's 0, 0. What's my b? So b is 0. Okay, so I got that. How do I find the slope? Yeah, think back.
Isn't it tangent rise over run?
It's rise over run, right? No. No. Inverse tangent finds me angles. I have the angle. Okay? So, how, way back in Algebra 1, we said rise over run, right? But in order to do that, we need what? We need 2 points, right? Because that's what I need to rise to the other point, and I need to run to that other point. So I need 2 points. Do I have 1 point that we went through? Yes. Do I have a second point that we go through? What? But we're thinking rectangularly though, right? So what's another point that it goes through? It goes through the origin. What's another point that this one goes through? And? How'd you get that? It goes through this point right here. On the unit circle, 3 pi over 4 goes through that rectangular point, right? Negative root 2 over 2, comma, root 2 over 2. So how do I find the slope between 2 points? So which one goes on top? Subtract the y's or subtract the x's? Y's on top. So I subtract the y's. So my slope here is going to be 0 minus the square root of 2 over 2 over 0 minus negative square root 2 over 2. Subtract the y's over subtract the x's, which is negative square root 2 over 2 divided by positive square root 2 over 2, right? Which is really what? Negative 1. So my question to you now, okay, what else at 3 pi over 4 is negative 1? What else at 3 pi over 4 is negative 1?
The tangent.
The tangent. Tangent is. Okay? So I'm going to give you now a fifth tool. The slope of any line is the tangent of the angle. So the slope is equal to the tangent of your theta. So the equation, the rectangular equation of this line is y equals negative 1x. Really, it's negative 1x plus 0, but we don't write that plus 0. Okay? You find me now the equation of number 8. So that's my line, right? Because that's at 60 degrees. Okay? So the tangent then, or my slope, is going to equal the tangent of 60 degrees, which is going to be the square root of 3 over 2 divided by 1/2, or simply put, just the square root of 3. Do I go through the pole? Yep, go through the pole. So then my equation is going to be y equals the square root of 3 times x. Now, yesterday we had a line that didn't go through the pole. Okay? And so I'm going to bring you back to yesterday's example. This was a line that didn't go through the pole. Okay? And that's what the R equation would be. So yesterday and the beginning part of today, you started in black, worked through the blue, got to the maroon. Today, you're starting at maroon, working through the blue, getting the black. It's the same steps, you're just going in reverse now. Okay? Same algebra, using the same 5 tools. Okay? Do number 9, please. Negative 2 cosecant of theta. Do I like it as written? R equals negative 2 cosecant of theta. No, how could I rewrite it?
Since you know that cosecant is 1 over sine
Like it? Now what? Multiply both sides by sine of theta. So that would give me r sine of theta is equal to -2. So y equals -2 because y equals r sine of theta. Yeah? What shape is y equals -2? It's a line, horizontal line, 2 down from the origin, right? Okay. So if we had to, we could graph it. Right? And if I had to, I could, oops, there it goes, maybe. What was it, -2 cosecant? It would go right over the top.